Now we're going to review a very important concept. It's called a function. You have learned in some other math class, a function usually we use f of x to show this is a function of x, and sometimes we use y to express this f of x. So let me give you a couple of examples. F of x equals x squared. How do we understand this? I would let you to imagine that your f function is like a magic box, and this magic box has a little note here, f here, and this is the function. And here's the hole. You're going to put in some value, x, and then down there's going to be something goes out. And what goes out is f of x. So you think this is like the magic. If I give you a function, I give you 1x, you put in, you shake it, you work on it, and then you let it function, right? And then you get out, you have only one f of x, only one value here. So this is a function. And for example, if I give you a function f of x equals x squared, if you put in x here as 1, you put in 1 here, you shake it, and we know f of x equals x squared, you shake it, so 1 squared comes out 1. And then if you put x equals 2, then f of 2, you square it, you kick it out, that will be 2 squared, which is a 4. All right, so you can imagine this. Whatever you put in, you shake it and then square it and kick it out. So that's the input and output for this function. What about if you put an apple in the box? It's not a number, but whatever you put in, remember I said whatever you put in, you just square it, right? And what about if you put in this box, and then whatever comes out is going to be this square. So this is the nature of the function. Function, it was like the transformer. Okay, so you're getting x and it came out as f of x. So input, output, input, output. So that's how this function magic box works. All right, now let me give you two examples. The first one, f of x equals x squared plus 2. Okay. So let me ask you, what is f of 0? Then f of something, you can just think this x is something equals that thing squared, then plus 2. So f of 0, you just substitute this x with 0. So f of 0 will be, that's f of something equals something squared, so which will be 0 squared, then plus 2. If you compare this two, you see what I mean, right? You substitute this x with a 0, so substitute this x with a 0. So the right side. And 0 squared is 0 plus 2, you get 2. What about f of 10? So f of something is that thing squared plus 2. So f of 10 will be 10 squared plus 2, so which is 10 squared plus 2, and that is 102. Sounds good? All right, keep going. I give you a second function. And you might say, well, this is a g. Yes, you can use any letter to show the function, just like you can just get another magic box and you put a little g here, and whatever you put there goes out is g of x. This is also, here, see? This is also a function, just another function. Even I write it as f, because sometimes I just use f and it also means function, okay? It might be a little different. All right, now, this one is 2x plus 1. Okay, so by looking at this, we think this is a box, a magic box. I put in whatever number or whatever thing, then I just double it plus 1. So if I put a, a house, then double the house plus 1. I don't care what I put in. I just double it plus 1. That's the function. That's how this function works. All right. So what about this? What about a g of 5? G of something is something doubled, then plus 1. So there will be 2 times 5, then plus 1, because you double the 5, you get a 10 plus 1, you get 11. So g of 5 equals 11. What about a g of negative 5? G of negative 5, you double it, plus 1. So that would be 2 times negative 5 plus 1. That's negative 10 plus 1, you get a negative 9. Okay, so you get the idea about this, how function works. Now I'm going to talk about one more thing which confused a lot of people, is the composite function, which is f little circle g. Okay, sometimes they do this. What does that mean? That means f of g of x. So that's a function of a function. What is that? You put in x to this g box or g function, you get something, and then you treat that as the input of the f function. You see, so I know g of x is 2x plus 1, so I get 2x plus 1. So from here to here, I didn't do anything, I just replaced that g of x. And then f of something, do you remember this? F of something is a something squared plus 1. So f of whole thing here will be the whole thing here, square then plus 2. Okay, so this is the new function, which is you put in x, and then you get a double it plus 1, you square it, and then you plus 2. That's how it works. So what about a g of f x? Well, that is a g of f of x. Let's see. Okay, so that would be g of, and the f of x, we know that is x squared plus 2. And the g of something is a something double plus 1. So g of this guy is this guy double plus 1. Phew. If you expand this, you're going to get that this is a 4x squared plus 4x plus 1, and plus that, you're going to get this plus 3. However, this one you get a 2x squared, and you get x squared plus 4x, double it, you get a plus 8x, and then 2 squared is a 4, times that is 8, times 2 is 8, then plus 1, you get a 9. Okay. Oh, sorry, this is a 4. I shouldn't square that. Okay, so that's 2x squared plus 4 plus 1. Then that is, see, I made a mistake too. So 2x squared plus 5. So what can you tell? What we're saying is f of g is not g of x. They're totally different functions. So this tells you what is a function, and this box will help you to understand the nature of the function. And also we talked about the composite function, and you can see that f of g is not the g of x. And this little circle, you got to be very careful, because usually you don't see this operation anywhere. This is the operation of a function. So f circle g means f of g. G circle f is g of f of x. And sometimes you see f circle f. Okay, so you should know how to do that. And that is f of x. And then you can just continue and figure that out. Okay, so this is everything I think right now we need function. Thank you.